Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I am going to solve one problem from the topic signal flow graph to find the transfer function using Mason's gain formula. So before going to solve the problem, let me explain about the Mason's gain formula. The Mason's gain formula C by R equal to 1 by delta summation K Pk del K, where K is the number of forward paths. Let me explain the terms. Delta equal to 1 minus sum of all individual loop gains plus sum of gain product of all combinations of two non-touching loops. So individual loop is a loop. It is a closed path and it start and end at the same node. That is called as individual loop. And plus sum of gain product of all combinations of two non-touching loops minus it will be continued further to find the delta. K equal to number of forward paths. And where delta K equal to delta for the part of the graph which is not touching kth forward path. If, for example, if for the signal flow graph, the number of forward paths is 2 means we need to find out delta 1 and delta 2. And after that, we can substitute in the Mason's gain formula to find the transfer function of the model. So let me solve this problem using Mason's gain formula to find the transfer function. So this is the given signal flow graph. We are going to find out the transfer function using Mason's gain formula. So let me start solving the problem. First, let me number out the nodes. I am numbering the nodes 1, 2, 3, 4, 5, and here one node is there. So number 6. Okay. The first step is to find the forward path gains. What do you mean by forward path? It is the direct path and it should start at the source node. It should start at the source node and it should end at the destination node. Input node to the output node without returning path, without taking returning path. That is the forward path condition. We need to find the forward path in the given signal program. CR, this is the first node, which is input node, and R to C direction should be in the forward direction. There should be no returning path. So R to C means we can take this as forward path. Let me draw that. So this is the forward path from node 1, 2 and 6. Let me number out the nodes. 1, 2, 6. And sub branch gain is given as 1 to 2. Branch gain is given as 1. And 2 to 6. Branch gain is given as 1. So we can find out the forward path gain. So forward path gain is nothing but we can denote that as P1. This is the first forward path, P1 equal to 1 into 1 product of branch gains which is equal to 1. So we can find out, let me search for another forward paths. There is no other forward paths, only one forward path which is R to C here, 1 to 6th node. This is the only forward path. Okay. So we can conclude the K equal to 1 here. Okay. K equal to 1 here for the given signal flow graph. Number of forward paths is only one forward path. So let me find out the next step. The step 2 is to find out the individual loop gains. So for that gain, first we need to find how many individual loops are there in the given signal flow graph. So individual loop is nothing but it is a closed path and it should start and end at the same node. That is the condition for individual loop. So let me search for the individual loops in the given signal flow graph. See the second node to third node, it is in the forward direction. And from the third node to second node, one return path is there. It is nothing but the feedback loop. Okay, feedback loop. So here we can take this as one individual loop. And see the fourth node to fifth node. After fifth node to fourth node, there is one returning path. So we can take this as another individual loop. And see the third node, third, fourth, fifth. And from the fifth node, it is returning back to the third node. So we can take this as third loop. So there are 3 individual loops in the given signal flow graph. Let me draw out that. Let me draw that. So first, second to third, okay, and then from fourth to fifth, and third, fourth, fifth. Okay, so let me write the branch gains in that. Let me number out the nodes and write the branch gains. So from second to third, this is the returning path. The branch gain is given us, that is feedback gain. And here the branch gain is given as s power minus 1 and here minus 2. And from fourth to fifth node, branch gain is given as s power minus 1 and here returning path gain is minus 3. And from third node, third, fourth, fifth, after fifth node, it is returning back to the third node. That branch gain is, returning branch gain is given as minus 3. And here third to fourth, sixth, and fourth to fifth, s power minus 1 is the branch gain. Okay. So let me find out the gains. Loop gain, individual loop gains. So we can take the first loop gain as L1. We can denote that as L1. L1 equal to product of branch gains, which is minus 2 into s power minus 1. We can simplify that as minus 2 by s. Minus 2 by s. And here for the second loop, loop 2, L2 equal to, loop 2 gain is L2 equal to minus 3 into s power minus 1. We can simplify that as minus 3 by s. And loop 3, we can denote that as L3 equal to 6 into s power minus 1 into minus 4. This is minus 4. 6 into s power minus 1 into minus 4, which is minus 24 by s. Okay, so we have found out the individual loop gains. The next step is to find out the two non-touching loops. Now compare L1, L2 and L3. We can find out which are the non-touching loops. Now compare L1 and L2. Compare L1 and L2. L1 includes second and third node. L2 includes fourth and fifth node. So really that are two non-touching loops. We can find out the gain by multiplying the gains, multiplying the loop gains. Okay. So here compare the third loop with first loop and second loop. Here the third loop includes third node, fourth node and fifth node. So it is really a touching loop only. It is really a touching loop only. So we cannot take out that for non-touching loop. So L1 and L2 is the only one combination of non-touching loops. We can take this as two non-touching loops. So that gain, we can denote that as NT1. One pair of non-touching loops. So what is the pair? L1, L2 combination. So we can multiply the gains. Minus 2 by s and here minus 3 by s. So minus 2 by s into minus 3 by s, which is 6 by s square. Okay. So using this forward path gain and individual loop gain and non-touching loop gains, we can find out the delta. And before finding out the delta, we can find delta 1 here. Delta 1 equal to delta for the part of the graph which is not touching the forward path. So this is the forward path. So compare this forward path with the signal flow graph. Now compare this forward path with the signal flow graph. We can with the signal flow graph and this loop. Okay. So here this forward path includes 1, 2 and 6th node. And compare the L1, L2 and L3. Find out which are not touching this forward path. Here first individual loop includes second node. And here also forward path is also having the node, also includes second node. So we cannot take out that L1 and L2. We can compare L2. L2 includes fourth and fifth node and forward path includes 1, 2 and 6. So this we can take that as individual loop. Okay. To find the delta 1. And compare L3 and forward path. Here also L3 includes third, fourth, fifth node. And here forward path includes 1, 2, 6. Okay. So we can take this L3 also individual loop for to find the delta 1. So we can take L2 and L3, L2 and L3. So 1 minus sum of individual loop gains. So what are the individual loops can be taken for this forward path? L2 and L3 combination. So L2 is minus 3 by S and L3 is minus 24 by S. So here we can simplify this as 1 plus 24 by S. Okay. So 1 plus 27 by S. 24 plus 3 is 27 by S, which is L S plus 27 by S. So we have found out the delta 1 here. So in the next slide, let me find the delta. So already in the Mason's gain formula, we have seen 1 minus sum of individual loop gains. Here we are having 3 loops, L1, L2 and L3 plus sum of 2 non-touching loops. Here only one pair of non-touching loops, which is the combination of L1 and L2, that we denoted as NT1. We found out the product. We can substitute the gains. L1 is nothing but minus 2 by S and L2 is minus 3 by S and L4 is minus 24 by S. Plus NT1 is the combination of L1 and L2, a product of L1 and L2, that is 6 by S square. Okay, let me simplify this. 1 plus 29 by S plus 6 by S square, which is simplified as S square plus 29S plus 6 by S square. Okay. Now using Mason's gain formula. What is the Mason's gain formula? We can find the transfer function using Mason's gain formula. 1 by delta summation k pk del k. Here k equal to 1. Number of forward paths is 1. So only P1 del 1 by delta. P1 delta 1 by delta. So already P1 we found out as 1. P1 equal to 1 and delta 1 we found out as S plus, let me see, S plus 27 by S. S plus 27 by S. We can substitute that. So 1 into S plus 27 by S by delta. Delta part is this one we found out previously. So we can substitute that S square plus 29S plus 6 whole divided by S square. So 1 S get cancelled. It is simplified as, the transfer function is simplified as S into S plus 27 by S square plus 29S plus 6. This is nothing but transfer function C by R. We found out the transfer function for the given signal flow graph. Okay. This is Mani's Gate Tech Vision. This is the channel Mani's Gate Tech Vision. This is the channel for engineering lectures. You can subscribe to the channel. You can view freely. This is my mail ID. You can ask any queries. Thank you very much for watching the video.